In this video, we are going to be learning how to calculate the theoretical yield in a balanced chemical equation. Now, what is this theoretical yield? Theoretical yield is the yield that we can get from the stoichiometric relationship between the reactants and the product. That is, in a chemical reaction, we have the reactants, and then we have also the product. So from this theoretical yield, it's telling us what we are likely to get from that balanced equation. But in the real sense, it's not always what we get. We also have what we call actual yield. Actual yield is the exact thing that we are able to get from the real practical um, experience of what we have done. So here we are going to be calculating how to we're going to find out how we can calculate the theoretical yield based on the question that we have here. And there's another thing we should also note. Another thing we should also know that in every chemical reaction, there is always a limiting reagent. This limiting reagent determines what you are likely to get. So the limiting reagent is what really determines when the reaction will end, because they are not enough. They are insufficient to carry out the reaction. So based on that, now we're going to be looking at some some questions here. The first one we're going to look at is it said that 0.25 grams of calcium carbonate react with excess hydrochloric acid according to the following balanced equation. Calculate the theoretical yield of carbon dioxide in SPP volume. Now that's the balanced chemical equation that we have. That's the balanced chemical equation, as you can see from there. To give us calcium chloride, we have water, and then plus carbon 4. So from the question given to us, that means our attention is more on the calcium triazoxide carbonate or calcium carbonate and what carbon dioxide or carbon 4 oxide that is produced. So based on this, we know that the hydrochloric acid is in excess. Hydrochloric acid is in excess, so that means we are not really trying to. That means we already know the one that is the limiting reagent, which is the calcium carbonate or calcium carbonate. So to do this reaction, to carry out the reaction, the first thing we do here, we look at the mass that we've been given, and then we relate it with what we have here. But based on this, you know that we are talking about STP. The total mass of, okay, let's start from the moles. The mole of this is 1 mole is to 1 mole. Then this is 0.25 grams of calcium carbonate. That means we need to find the mole ratio of this. To get the mole ratio of that, what we have is, remember that mole is equal to mass over molar mass. Molar mass of carbonate is 100. So what we do here is 0.25 over what? 100. That will give us 0.0025 moles of what? Calcium carbonate. From this ratio, we notice that mole ratio, we find out that 1 mole of this is 1 mole of that will be, and that means 25 mole of this will be equal to the number of moles of carbon 4 that we are going to be produced. Now, remember, the question is in volume. We need to calculate it in volumes. So getting it in volume means we're going to be using, you know that mole is also mass and volume over molar volume. So in that case, we have our mole to be 0.0025, volume, the small volume we don't know, and the molar volume is always 22.4 gm cube. So what we do here, if we cross multiply, we are multiplying 0.0025 multiplied by 22.4. That will give us 0.025 gm cube of volume. That is what we have. So we can also take it another version. We can also take it another way. Now we can go by taking it by masses. We have 0.25 grams will give us, okay, 100 grams will give us 22.4 gm3 from the balanced chemical equation. 0.25 grams will give us 22.4 over 100 times 25 over 1. That will give us, if you multiply it, we will have 0.056 gm cube. So the next question we'll be doing it, we'll be solving it in our next video. So thank you so much for being part of the class, and remember to watch the next video that's coming up. Thank you.